I will be. Next year I do want my student teaching. I'm an education major. And then I'm done. So I can go back and get my master's.
Do you have an idea of where you want a student to teach at?
Not Ironton.
I know my school has a lot of student teachers where they're sort of, but a lot of people don't want to teach there if they're from this area.
My siblings are enrolled in Ironton at the moment. One's a junior and the other one is in 3rd grade. And I cannot stand the school. Cannot stand the principals.
I like a lot of the schools around here.
And
really do things like they're supposed to.
And that's what I was going to say. My sister, who is a sophomore, knows nothing. And she's a sophomore, and she should not be. You know what I mean?
Because like even I know there's like a 100% graduation rate. So like you always graduate. They that's impressive. So what it tells me is that if they fail, then they just keep going.
Yeah. Well, that's what my younger sister's having issues now because she doesn't understand. Poor thing, she thinks she's going to be a nurse.
One of my friends thinks he's going to be a doctor in college. It was a decent ACT score, but not like you're going to get every test.
You know what my sister got in her first ACT? 14.
Oh, but
Yeah. She won. It happened. She's got dreams, I guess.
hey, dreams is something.
Dreams that will never come true.
I'm having trouble with coordinating. I got 16. So you can try schools.
Showing like everything.
What page number did the second assignment start on?
27.
I thought contingent. Hello! It smells funny. Does it smell funny to you? I think it smells funny.
maybe because I was having fresh air and I had to get down in this dim room. Now there was quite a few people here last time.
This semester. And I think the book may want to encourage me,
Alright.
Probably not too well, but
What is it? Okay. No, usually everybody takes the lead. I know it is. I'm just getting grown up, so I can last look up someone. Usually it's there.
that's what I figured. She was like,
She'll give you
That's why I texted her yesterday.
the backgrounds, how to do the process.
That's what I was going to ask you, but I didn't do it. I apologize if I wasn't married the first day. I know. I don't because I sat like I knew you, and then the girl that I sat next to in my class right after
In case they're price, you get
stopped her.
invited. I got confused.
that's the one I know I don't, right?
Because usually one's like freaking word. If you just my problem is trying to get it so
Yeah, that's
like the first one, maybe I can get that this hand, right?
They like separate every single thing.
This
That's spread it out. It's hard to it's so because you
this is loose. Go glad it's which stuff.
once you this point,
by like a year.
then you like cross the off. You know that it doesn't make sense. It's so much
Yeah, I just do like podcast.
yeah, they have.
Have you taken science classes? You haven't, so you'll probably take it next semester.
I'm not in language arts, so I just have to do it.
We don't have enough people for our methods course next semester. So
Next semester?
yeah, for science. Chris Hawkes teaches it, so he said he's never done a network class before though, so he's not sure if they would do that. But you think they would? Yeah.
Our math.
Yeah, our math is like that. Emily's in it with us. Writing A's. Have you guys submitted your homework yet? Writing A's.
For this?
You already did?
No.
Yeah. That I didn't know like if it was.
I know,
due
looked
today
at last night.
before.
It said 11:59 p.m. Yeah.
Yeah, I thought it. I didn't know if it was like it was due the day before. So I just turned it last.
So, if N is prime, then it's work.
I'm going to recount my homework.
So I did it normal if N. I know there's gonna be but if it just says or something,
I can't
you just
have them
do it again.
mixed in with you.
It's
Like,
like you have to.
How do you explain?
yeah, so
How do you
let's
explain?
interactive.
That's the
Alright, now which?
whatever.
So this outline.
It's like to do.
Can I do something like that?
Yeah,
But then
that's what
I was
that is.
thinking,
So
last time I overachieved for the assignment and I didn't even collect it,
Yeah,
so.
that's what
that's it.
Yeah, I actually did go through and like, I probably will do a tiny paper and just answer the question.
I will be doing that. I was trying to
Do you
understand.
have that little stapler on you? I got 5
Yeah,
pages in
negation
last
is-
night and I was like, alright.
I don't, I
You
You
like
know
don't
that's
put
okay.
it then and
Yeah, I know you know.
Right, so I got it in fine.
Actually, I don't need a stapler because I'm gonna staple a little thing
Oh,
right
okay.
here, so. I don't need it yet.
Yes. That's it.
I got
I didn't know if we were supposed to do like
Yeah, for me,
one more page. I gotta make it even. So I
Right,
thought,
right,
I don't know if that's right,
someone,
but that's what, like,
Yeah,
I
I
just
did
think
like
it's
an
like-
outline.
if it
and
seems
then
like
I
the second
highlighted
part of the
it.
statement, if it seems
I
like.
got to like,
Because
because
this
what I
is
was
if
did with this was I just
this,
answered
then
the 2 questions
this.
of the title.
Since there's 2 parts
But
in that,
anywhere in between
that's
where I
fine.
knew I
I
was
don't
going
know
to
if
get those
that's
questions
correct.
answered, I just
I
highlighted
kind of
things.
wing it.
I literally just went.
Yeah, I highlighted stuff that I thought was important, or if he asked if we noticed stuff in class, I'll be able to point out that I like.
If it said, for example, I skipped it.
Yeah, there was a lot of for examples. What would you?
I tried to skim it yesterday.
Okay, we're gonna get started. First check attendance. Megan. Here. Austin. Elsa. Here. Morgan. Morgan. Allison. Here. Katie. Here. Danielle. Lena. James. Jesse. Here. Leah. Here. Catherine. Here. Madison. Curtis.
Here.
All right. Let's take well, there's homework due today. Does anybody have any question about the homework assignments due today? The words and symbols? Yes?
Morgan is here.
Okay. Is Madison here yet? Okay. So you're talking about the first problem, right? The first question?
It's just process.
Did you say? You mean this one, right? Is that right? Okay. All right. So number 16. I can do an example from the textbook. It's 1.1.
What's your major? Or you just?
I'm still in high school.
That's 1.2.
She's doing the Bible.
Okay, I'm gonna do number 17. It's not a homework, but it's similar to number 16 in the text in the exercise. Okay, because James has a question about homework number 16 from section 1.2. So next I'm going to give you an example similar to that. And what the one I'm going to do is number 17 in exercise. So it says if this is from section 1.2. So the question says if Rob is a goalkeeper and Aaron plays forward. goalkeeper, or Aaron does not play forward, or Sam plays defense. All right. Okay, so it's kind of this question is kind of similar to the homework assignment. If you pay the full price, then you didn't buy it at Chromebooks. If you didn't buy it at Chromebooks, or you paid full price. So the question is, they want us to write each of the statements in symbolic form and then determine whether they are logically equivalent. Include a truth table, a few words of explanation. Okay, so first thing, the one I'm going to do is more complicated because I have 3 statements, which you only have two statements, 2 simple statements. So look at the example here. We are going to, so there's a statement which says Rob is a goalkeeper, and we use symbolic form. When you do symbolic form, you can use symbols to represent each statement. So this simple statement, we can call it, let's see, of course, different statements, you gotta use different letters, variables. Let me see which one. I can use the first letter, maybe R of each person's name, Rob, A, Aaron, and S, Sam, to represent the whole statement. Or if you want, you can use G, goalkeeper, for goalkeeper, and F, forward, and D, defense. So it's up to you. So I'm going to use the first letter R. So that's so R means Rob is goalkeeper. A means let's use this. A means Aaron plays forward. S means Sam plays defense. So first of all, you have to specify that. I just mark it here to save some writing. You can do that, the same thing, or you can rewrite it if you don't think that's very clear. You can write down R means R represents Rob is goalkeeper. Okay, now so this is the first statement. Okay, let's change that to symbols. Rob is goalkeeper. And what's the symbol for N? Upside down V, right? So you're going to have N for that. And then if the whole thing, so R, the hypothesis is R and A. If then statement, what's the symbol we use for if then statement? The arrow, right? Pointing towards the consequence or the conclusion. So the first statement becomes what? R and A implies S. Okay. Now the second statement, Rob is not goalkeeper. How do we represent that? Negation of R, or that's V, the letter V. Sort of like V. It's not really V, but it looks like V. Aaron does not play, does not. That's negation of A. Or that's V again. And Sam plays defense. That's the same as S. Okay, so here I'm going to write down the 2 statements clearly. We have, first one is R and A. Put them together closer so we can see better. That's the first statement. R and A implies S. The second statement says negation of A, R, or negation of A, or S. So they want us to show these 2 statements are equivalent. Okay. So first of all, do symbolic form. That's the symbolic form. Secondly, we want to show that they are equivalent.
Would it be wrong? Would it be wrong to put parentheses around R and A in the first one?
You mean like this? No, it's right. That's correct. Okay. So, James, do you just have trouble with the symbolic form, or do you have trouble to continue?
No, I just have trouble with that.
Okay. All right. So when you go back to the homework question, So you can do the same thing. Make this, you can call it whatever. Say P, full price. You can call it P or F. And you did not buy it at the Chromebooks. You can call it whatever letter you want. You can call it Q or anything. And then you can, that's the first statement. It's conditional statement. And do the same thing. And then you're going to use the letters you picked for the second statement. Okay? And after that, how do you show that they are logically equivalent? You will have to draw the table like we did last time. We did example last time, so I just want to show you that table a little quick here. Sort of like this example. You have to create columns, and this is for the left-hand side. That's right-hand side. You show that they have matching truth values. So you would do the same thing for this one. Okay, but this one is very similar to that. We have three simple statements. So you will have to create a column for R and A and S and do find truth value of this for all the different 8 cases and do the same thing for that. But the homework question, the one in homework, should be much easier because you only have 2 statements. So you should only have four possibilities. Okay, so that's the homework example for 16. Does anybody else have any question about the homework that's due today? No? Okay. So at the end of the class, I gave you examples to explain sufficient and necessary condition. Do you have trouble doing the last 2? Because I guess I only gave you 2 examples. I don't know if you guys still have trouble doing like number 43, 47, 48. Last 3 questions. Any question about these? Huh?
Nope.
No? No? Okay.
No.
Yes? No? Okay. If not, we will move on to 1.3. So for the students from other campuses, you will have to go to week 1 and just click on homework 1 and attach all your pictures. And students from Southern, you can just give me the hard copy of your homework. So now let's look at 1.3. Valid and invalid arguments. Okay, so in our first class, I gave you a little bit of introduction about the class. I said we're going to learn a lot of proofing techniques, different methods of proofs. Well, when you write on the proof, it's like an argument. You have to say, because of this and such and such, I should get this and that. You get a conclusion. But your because part, because of your policy, from your syllabus. And if you have a 93 or higher, and we should get an A, and I do have 94, then I should get an A. So that's argument. And your argument, you have a conclusion which says I should get an A. Well, let's we can kind of look at this because by the policy in your syllabus, by the policy in the syllabus, if a student, what I can say if let's put if I instead of if I get 93 or higher, then I should get an A. And because I have 94, I should get an A. So that's the argument. And this is, I would consider this as a valid argument because what you're saying, your conclusion, this is your conclusion, get an A. I would say this conclusion is valid, or the whole argument is valid because you said the policy in the syllabus. So I would go check if I do have this policy in the syllabus. And so that's the policy. And I do have this policy in my syllabus. And then next thing I'm going to check is, you said you have 94, and I will have to check if you do have 94. If both of them are true, and then I should give you 98, get an A, and that would be considered a valid argument. So look at this whole thing here. We have these two parts right here. The first policy, which is written there, and there is another thing. These both things are, we call them premises. And well, it's like the reason for you to get an A. That's the conclusion. Okay, so this is an example, a very simple example of argument we use in real life. And notice that if you say something like, suppose you did give me this, but I went to check. I found out your average is 90. I would have to tell you what? Well, sorry, your argument is wrong, okay? It's not valid because you don't have 94. You have 90. That will be considered as an invalid argument. Okay, so we talk in this case, this is an obvious mistake, or maybe I don't even have this. So maybe in my syllabus, I went to check, I should get a 95 or higher, and then you won't be able to, this will be false, right? So this premises will be false, and then, so either one of them, I have two in the premises, two statements in the premises, either one of them is false will not be a valid argument, okay? But maybe there could be a case like this. So a different argument would be the policy, by the policy in the syllabus, because I have 84. Suppose say you have 84. I have 84 instead of 94. I should get A. Will this be a valid argument? No, because it says you have to get 93 or high, although your premises are true. This is in the syllabus, and I checked it. You do have 84, but your conclusion is wrong, right? By the logic should be if you have 93 or higher, that will give you A. If you have 84, you're not going to get A. That would also be considered as invalid. So this is what we're going to do in this section. When you write on the proofs later, everything you say, because of this or because of that, you got to make sure that is true, okay? You cannot give me false assumptions because or give me something that's not even given in the problem. For example, later we're going to do a question if A squared is even, then A is even. If a number squared is even, then you got to prove the number is even. So I get a mistake a lot in the past. Some students say because A is even, and that would be considered wrong because I ask you to prove the number is even, and you tell me because A is even, that's not even true, right? Okay, that's something we don't even know. So whenever you write on the argument or proof, make sure everything you say, the reason part that we call premises here, you gotta make sure they are true. There cannot be anything false. And also the conclusion has to be true. Okay, there's a formal definition of argument. What's an argument? Argument is a sequence of statements. You can keep. I don't really think you need to memorize the definition. A sequence of statements. You can refer to the example that I just gave you. So look at the example. This is an argument. As you can see, what's argument? You got a bunch of a sequence of statements, and And the other thing we mentioned would be, the next part is, let's see, it's kind of long, the copy down the whole definitions. So next part we call, in the argument, all statements in the argument, except for the final one, are called premises. Or you can call it assumptions or hypothesis. Assumptions, with different ways to call those, assumptions or hypothesis. So let's look at the example again. Like I said, the last sentence, this is the final sentence, final statement. This one we call it conclusion. This is conclusion. But all the previous sentences, all of these statements, we call them premises, or we call them hypotheses or assumptions. The conclusion part is the one you want to prove. Everything before that is the explanation, the reasoning you provide. Okay, so the premises, assumption. And the final one, we call it, the final statement, we call it conclusion. The final statement is called the conclusion. Okay, now that's the definition, but use this example to help you remember it. So the whole thing is called argument, and last sentence statement is called conclusion. Everything before that are called premises or assumption or hypothesis. Now, the next thing we're going to talk about is valid or invalid. So when will be an argument considered valid? I gave you examples, but let's look at the definition. So to say, what's a valid argument? An argument is valid or argument form is valid. Means that no matter what particular statements are in the statements are substituted for the statement variables and its premises, if the resulting premises are all true, then the conclusion is also true. So that's valid. Okay, so when we use this example, so the definition is kind of long, but the key points are this. If all the premises are true, then the conclusion is also true. So that's the main thing here. Well, we can look at the example we had here. So the premises, we got two of them, two premises. And I have to make sure that the first premise assumption is true. If I do have this in my syllabus, it's not 94 or 95. If I do have this listed in my syllabus, then I will say, okay, this first assumption is true. And then the second one, I have to go check to make sure, yes, you do have 94 and not 84 or anything else. And if you do have 94, then I'll mark that's also true. So that tells me all the premises, two premises are true. Then the conclusion is also true, and I will check, okay, yes, the conclusion is also true. You should get an A. So that would be considered as a valid argument. So in the other words, what would be invalid? The invalid, well, when we consider invalid, you may say, we still have to make sure you give me the correct premises. So this has to be true, this has to be true. Invalid would be you got a wrong conclusion. So for example, because I have 984, I should get an A. That would be considered wrong. Although the premises are true, your conclusion is false. The whole argument will be considered false. Okay, so let's look at specific example to explain this. Example 1.3.1. So we want to show that the following argument is invalid. I think I'm going to actually switch then. Let's start with 1.3.2 to look at a valid argument. Then we're going to look at an invalid argument. Form is valid. P or Q or R. Negation R. Those three dots right there. My paper is okay, so if you have those three dots that looks like a triangle, three dots, and that means therefore so therefore P or Q. Now in this argument, we don't see a specific sentence like the example I gave you, but you should know P represents some kind of statement. Q represents some kind of statement. R represents some kind of statement. So this is like saying, well, because we have this P or Q or R, and also not R, therefore we should have P or Q. So that's the argument. Now, when we just look at it, it's hard to tell whether it's valid or invalid. So we're going to draw a truth table to do it. Notice that we have three simple statements. We're going to have all the 8 possibilities. One, two, three, 4, 5, 6, 7. We start with creating columns for each simple statement. P, Q, R. P, Q, and R. Right. Remember how to list all the 8 different possibilities? Okay. So I have that. Well, I'm going to go ahead and do that. Last time I gave you, Wednesday, I gave you a table, a tree diagram to help you if you forgot how to do that. So you're going to follow this P, Q, R. So P, 2 possibilities, Q, 2 possibilities, no matter what P value is. And then for R, you also have, for each case, you have also 2 possibilities. So you're going to have to go through the tree branches to get all the 8 different possibilities. So I'm going to have TTT, TTF, TFT, TFF. I'm going to change P2, the value of P to false. FTT, FTF, and FFT, FFF. Okay, so that's all the 8 different combinations of the true values of these 3 simple statements. So now we're going to look at, by the way, if you look at the argument form here, which statements are considered premises? This one is premises, right? And that one, okay? So everything except the last one. The last one is called conclusion. So this is our conclusion. And these two are both called premises. Okay, so now we can first find out the truth values of the premises. Well, there are two of them. I think in the first premises assumption, we have to do two steps. Do the parentheses first, Q or R, and then P or Q or R, and negation of R. So let's work out these three premises. Q or R. In disjunction, if one of them is true, then it's true, right? Can someone volunteer to give me the truth values of Q or R? Anybody? True, okay? True. Yes, okay. Good. Now next we do P or Q or R. So we already have the truth value of the second, what's in the parentheses. You're going to look at this column and that column. Because when we have so many columns, sometimes we look at the wrong columns, then you're going to get the right answers. So look at them. True or true? We still get
True.
Yeah, true or true, true or true, true or false, false or true, false or true, false or true, false and false, false or false, false. Okay. Now let's do negation. Would be the opposite of the third column. Just reverse it. FT, FT, FT. Okay. All of these three. Well, not all these three. So premises, we got two of them. These two. So we can mark these two as our premises. Because later we do have to check the values of them. Now let's write down the conclusion. There's one statement in the conclusion, which is P or Q. Let's copy down that, P or Q. When you can give me all the truth values of P or Q, or it could be a little bit easier, because by the definition, go back to take a look at the definition one more time. So the definition says, what's a valid argument? If all the premises are true, and also the conclusion is also true, that would be considered a valid argument. So, first you can take a look at the premises. You have to have, in order for the argument to be true, you have to have both true premises. You will not be able to give me something wrong. Say you actually have an 84, but you tell me you have a 94, and that means your premises is wrong, and you won't be considered as a valid argument. So that's why, look, like this case, the second premises, in second statement, the premises is false, and that one, you don't even have to check the conclusion anymore, right? Just like if you have an 84, but you tell me you're 94, you have 94, I will immediately know it's invalid, right? Okay. So like those ones, you don't really have to look at them. If one of them is false, the first premises, or if maybe you tell me if I should get a 90 or higher, I should get an A. Then I was have to tell you, well, that's not what it's in my. That's not what I said in syllabus. You have to have 93 or higher. But if you tell me 90 or higher, that means your first statement is false. So for those ones, don't even have to look at them. You don't have to do that. You can do them, work out if you want, but really you don't have to worry about them. So we're only going to work on the ones with both true premises. Okay. Does it make sense? Okay, so in order to consider valid, you're considered as a valid statement, you cannot give me anything that's not a fact. Okay, so we're gonna, let's just work out these three. P or Q. So P or Q, that's T or T, that's T. And T or false, true or false, that would be true. And false or true, that would be true. Okay. The other ones, I didn't do them. You can do them. But even if you do them, work them out, you just have to ignore them, okay? Because it doesn't. When you check it whether a statement is valid, you have to make sure the premises are valid. And now look at the conclusion. They are also true. So true premises give us true conclusion. That tells us it's valid. So they call these critical rows. These are the rows that matters. Critical rows, but well, enough space. Critical rows. So only these 3 rows matter. And now you can say this is a valid argument. There. Okay. All right. So does anybody have any question?
You don't have to fill out the other boxes.
No, you don't. You can if you want, but you don't have to.
Okay.
Because because the definition says for a valid argument, you have to have true premises. For the other ones, they don't have true. One of the premises is wrong, is false. Then we're not even gonna consider them. Okay. All right. Just like when you come to argue with me, you're not gonna make up a policy in the syllabus. Say, okay, if I get 90 or higher, I will get A because I have 91. I should get A. Well, then I won't consider it as a valid argument, right? So because I have 93 or higher, you tell me it's 90 or higher, that won't be right. Or if you have 84, but you tell me you have 94, again, I would say, well, that's not valid because you have an 84, not 94. So whenever you consider something, an argument as valid, you gotta make sure all of these are true. True, true, true. Okay. All right, now let's, any other question? Now next we're gonna look at an invalid argument. So example 1.3.1. We want to show the following argument is invalid. Following argument form and invalid. We have P, if P then Q or negation R of R. Q, if Q then P and R. Therefore, P, if P implies R. We still have P, Q, R, 3 statements. We have to create all those columns. This one is going to be much longer than the other one. First, to create 3 columns, P, Q, R. You might want to make your columns a little tight because we have more columns this time. Okay, so what columns should we create? Look at first we look at the premises. That's our premises. We have 2 premises. We got to do each one. So the first one has, remember the order of these operations. What do we do first?
Negation.
Negation, good. So you're going to have to do, although they don't have any parentheses there, you may say from left to right, should I do the implication, conditional statement? No. Last Wednesday, I probably didn't write it down, but I didn't mark it somewhere. Implication is always the last step. Okay. So you have to start from negation first. Negation is always first. Implication is always the last. Okay, after negation, we got to do what's the next operation? The OR. Yeah, the OR statement. And after that, we're going to do implication. Because remember, this is always the last thing you're going to do. Negation is always the first, except if you have parentheses, I would go with the parentheses first. If you don't have parentheses, you got to do negation. Okay, make that. And then look at the second second statement, we have to do P and R, and then we got an implication. Okay. And the conclusion would be P is P then R. So in the textbook, they did a way, they put the two premises together. This one and that one. They switched these two. The reason they did that is so you can see them side by side. It's easy for you. But if you don't want to do that way, that's fine. You can just have to mark these two as your premises. And last one is your conclusion. Okay, so now I copied every operation down in my form, so I can go ahead and work this out. First of all, do all the 8 possibilities. TFT, TFF, FTT, FTF, FFT, FFF. Now, first we work out negation of R. So reverse the values. FT. Next we do the disjunction, the or statement of these two columns. Q, second column, negation of R, the fourth column. Again, because it's disjunction, if one of them is true, then it's true. So TF, TT. If both are the false, then you get a false. FT, TF, TT. Both are the false, then you get a false. FT, you get true. Okay, now the last step, we're doing the implication, conditional statement. So that's what we just covered on Wednesday, last Wednesday. So refresh your memory, see if you still remember that. I can show you that table we had before. Okay, so the truth table for conditional statement. If the hypothesis or the condition, the hypothesis is true, the conditional statement has the same truth value as the conclusion. But if the hypothesis is false, we don't have to look at the conclusion. It will automatically consider this as a true statement. Okay, so that's the truth value for conditional statement. So we're gonna go back here to, that's in this conditional statement, P is the hypothesis, and Q or negation of R, that's the conclusion. Okay, so here it's a little confused because as an argument, we have hypothesis and a conclusion, but in this, one of the first statement in premises, in hypothesis, we also, it's a conditional statement, but we have another hypothesis and another conclusion there. Okay, so P is the first column. P is true. I think the first thing we're going to do is the last four, these four cases, because the hypothesis for this conditional statement P is false. What do you say about the truth value of the conditional statement? If the hypothesis is false,
and the conclusion is true.
Yes, the whole statement it will be true. We don't have to look at the conclusion. Okay, so this will be true, 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 true. Okay, do you still remember? Do you all remember that?
Yes.
Okay, because that example that I gave you last time was if you show up for work on Monday morning, then you will get a job. But suppose you did not show up for work Monday morning, we automatically consider this is still a true statement. Okay? And because it did not show up, it cannot really, the whole statement that the boss told you have been considered as true. Okay, now the other ones, if the hypothesis is true, the truth value would be the same as the conclusion. So we're just going to copy that, T, T, F, T. Any question about this column? No? let's look at the next one, P and R. That's what we did last Monday and Wednesday, so that should be easier. For AND situation, you're gonna need both to be true in order to get true. So true will be true, but true false will be false. True will be true. True false will be false. False true will be false. False and false, it's false. False and true, false. False and false is still false. Now with that, we can find the truth value of the next conditional statement. The hypothesis is Q this time. Did I? Okay, yeah, sorry. So Q, it's the second column. Too many columns, sometimes we get confused. So this column right here as our hypothesis, focus on this column. And conclusion is that the column we just did. So look at hypothesis true, conclusion is true. That would make the whole statement true, right? Okay. If the hypothesis is true, but the conclusion is false,
False.
Yes, be false. But then for the next two, the hypothesis false.
So they're both true.
Yes, both would be true. Now the next two, true, then you look at the conclusion. So you get a false. And when you have false hypothesis, then your whole statement will be automatically true by default. Now the last, so we got the truth value of premises, and next we can do the conclusion. The conclusion for P, if P then R. So look at the first column and third column. Again, if the hypotheses are true, then the truth value will be the same as the conclusion, which is the third column, TF. But if the hypothesis is false, the statement will be considered as true by default. Okay, so that's what we have now. Look at how do we determine whether this is an argued. Well, we know we need to show it's invalid, but let's see why this is invalid. We look at focus on these two premises column first. Again, we are only going to look at the ones with the true. Well, it's hard for me to circle now because I shouldn't include this column, okay? So that's why the textbook put these two columns side by side. I can only do this because I don't need the premises. Look, it's these two, okay? I did this column because I have to use that column to get the truth value for the second statement in the premises. But we don't really look at, when you check whether the argument is valid, you only focus on this premises and that premise. So true. Well, look at the second column. True, false. So that means one of the statements in the premises is false. And you're going to ignore that because we won't need, when you do argument, you're never going to give the false assumptions. So the same here. The first statement is false. We ignore those. And the next one, both are true. And continue, false, we ignore them. And the last two rows, they are true. So technically, you can do the same thing, the ones like you can mark, if you want, you can mark those ones first. So you don't have to do the other ones. Like those ones, technically, you didn't have to do them. If you don't want it, you don't have to do the other ones we did not mark. And now we also look at the corresponding conclusion of these rows. That's true. So true premises give a true conclusion. And also for the last two, true premises give true conclusion, true premises give true conclusion. But there's one right there. This one right here. That one, true premises, you got a wrong conclusion. That tells you this is invalid argument. This tells you it's invalid. Okay, again, why it's invalid? Because your conclusion is wrong. And it's just really common sense. So the example we talked about, let's say you're telling me the policy in the syllabus says if I get 93 or higher, I should get an A. That is true. And because I have 84, suppose you got 84 instead of 94, you have 84. I look at your grades, you do have 84. And then you give me the conclusion, I should get A. So you have true premises, but your conclusion is wrong. And that would be considered as an invalid argument. Okay. All right. And so all you have to mark is circle the ones with true premises. If one of them is, one of the conclusion is wrong, if all of them is wrong, doesn't matter. If one of them is wrong, then you have to call this an invalid argument. Okay, questions about this example? No? Okay, now we are going to talk about some special cases of arguments. Special arguments we use very often in the proof or in real life. So one we have next we're going to talk about is called Modus Ponens and Modus Ponens. First of all, we call this special cases of arguments. Well, one is called modus. The first one is called modus ponens. The second one is called, maybe I can put them side by side, you can compare them. So that's one word here, modus ponens and the modus tollens. So these are two special types of arguments. But what is modus ponens? It looks like, the form looks like this. If P, then Q. You can use symbols if you want. P, arrow to Q. P, therefore Q. So that's called a modus ponens. I will give you an example to explain that. And what's a modus tollens? The first statement in the premises is the same. If P, then Q. But the second one is different. Negation of Q, therefore negation of P. Now look at an example of the first one. We have a rule to check. How do we check the next example we're going to do? How do we know whether a number is divisible by 3? Yes, that's right. The textbook has a very big number, but I'm just going to give you a small one, say 3,750. And when you look at it, it's not easy to tell whether 3 goes in here, right? Unless you divide them. But there's a quick way to check. You can add all the digits in the number, 3 plus 7 plus 5 plus 0. And we got 15. And 3 divides 15. Well, 15 is divisible by 3. That tells you 3 divides the original number, 3,750, right? Okay, so this is something we learned in algebra class or elementary math. So we're going to use that here. If the sum, so that's the example here. If the sum of the digits of 3,750 is divisible by 3, then 3,750 is divisible by 3. Divisible. Okay, the next part I would say the sum of the digits of 3,750 is divisible by 3. Therefore, 750 is divisible by 3. When you look at it, it's like repeating what we just said. So look at the first statement in the premise. So the first one says, if the sum of the digits of 3,750 is divisible by 3, then 3,750 is divisible by 3. It just says if, then. So that's like a formula, like a property that somebody tells you. What do you actually need to check next? What do we check? We're going to actually check add 3 plus 7 plus 5 plus 0. So that next part, in the next statement in the premises, use different color. The sum of digits of 3,750 is divisible by 3. How do we know that? We add 3750, right? And you get 15. And we verify that 15 is divisible by 3. You get a conclusion. Therefore, 3,750 is divisible by 3. Okay. So this whole argument right here is called Modus Ponens. And when you look at it, it's just because you verify the first statement in the premises says it's a conditional statement. It says if, then. Well, you do have to verify the sum of the digits is divisible by 3. So you got to verify that condition. Therefore, you will get that conclusion. If you don't have that condition, let's say if you add all the digits, you got 16, which is not divisible by 3, then you're not going to be able to get that conclusion either. Okay, let's look at...
Can you scoot the page up a little bit?
Okay.
Yeah, that's good. Thank you.
You're welcome. The example I gave you at the very beginning of the class, it's also an example of Modus Ponens. And because the first, what's the first statement? The first statement, it's an if-then statement. The first statement in the premises, if-then. What's the second? Second, it's just a P, which means you verify the P is true. Therefore, Q should be true. Okay. So the conditional statement says, if P is true, if you have this condition, hypothesis, if you meet this hypothesis, then you will have this conclusion. Or in the other words, if P is true, then Q is true. Therefore, you have to verify whether, next we verify whether P is true. If P is true, therefore Q is true. So that's what the whole her argument. It's very easy. We use that all the time. For example, when you come to argue with me, if I get 93 or higher, then I should have A. So our P will be, I get 93 or higher. And Q will be, I should get A. And because I have 94, so we got to go back to 94. That means you got a P. Therefore, I should get A, which is Q, right? So this is exactly a Modus Ponens example of argument. Okay. Any question about this? Okay. We just have a name. We know we are familiar with this kind of argument form, but we call it Modus Ponens. But Modus Tollens is a little different. We do use it in real life sometimes, but you may not realize you're using this kind of argument. So it says if P, then Q. Not Q, therefore not P. Does this look familiar to you? If not Q, then not P. What's that? What do we call this? Go back to, okay, so if P, then Q. Say it again.
Contrapositive?
Yes, that's right. Well, the way it's written, because of, as an argument, usually we say, well, not Q, therefore not P. But I can change this second part as as a conditional statement. That would be if not Q, then not P. If not Q, then not P. And from last class, we talked about those three concepts: converse, inverse, and contrapositive. That's exactly contrapositive. See, P implies Q. Negation of P implies negation of P. We call this conditional statement control positive. Okay. Well, so when you use the control positive in your argument, this argument is called modus tollens. And again, we can first look at a real life example. Suppose, so again, this is the syllabus. Instead of saying because I have 94, I'm going to change that to because I don't have A. Because I don't have A, I look at my grade, I have 84. What conclusion can you get from that? Let's maybe I can write this one more time. So the first statement says if I get 93 or higher, then I will get an A. Now I'm going to change the this is the same in the syllabus. So the second one, originally the example I had was because I have 94, I should get A. Now I'm going to change that to I have 84. Okay, both are premises. What would be the conclusion you would get? Oh, I'm sorry. That's not what I'm sorry. That's not what I meant to say. Because I said I have a B. Okay, where my grade I didn't get an A. Maybe I didn't get an A. Suppose you got an A minus or B. What conclusion can we get?
Then I didn't get a 93 or higher?
Yes, I didn't get 93 or higher. Okay, make sense? That's like doing contrapositive. You negate, I would get an A to did not get an A, and then you negate the hypothesis, I get 93 or higher, I did not get 93 or higher, and then you change the order. That's called a contrapositive. But when we write it in this form, this first statement comes from the syllabus. The second statement, it's a fact from your grade report. And the conclusion you draw is the logical conclusion. It's a valid argument. So that's just like common sense. And I probably did not verify that, but last time when we talked about, this is what we're gonna do today. The original statement and the contrapositive, we did mention that they are congruent. I think I had it last time. Maybe I didn't. Okay, well, if you use common sense, we know this is true. We actually can prove it by making a truth table. Well, you can call the first one P, you call this one Q. So you have a P, and P implies Q. I did not get an A, that's negation of Q. I did not get a 93 or higher, negation of P. You can verify the first statement, P implies Q, is congruent to negation of Q, therefore implying negation of P. So these two statements are logically equivalent by making truth table. And if you don't even do that, if you just say common sense, everybody can see that. They're talking about the same thing. Okay. And I guess we can do another example for modus. So this argument is called modus tollens. I'll give you another example right here from the textbook. So it says if Zeus is human, then Zeus is mortal. Okay. So we know a human is model, and that's true. So that's our first statement in the premises. Now, as a fact, we know whether it's true or not. Well, let's assume. So we know Zeus is what? Immortal, right? So it's not mortal. What conclusion can we get? Therefore, that's right. Zeus is not human. And this argument is called Modus Ponens. Okay, the next thing we are going to talk about is the I think some of the questions, like what I just gave you, some of the homework questions, they give you those three. First statement, give you premises. They ask you to draw the conclusion, and you cannot do that. Do you need more examples for that? No. Okay. So like that. So I may give you, they give the homework. We can take a quick look at the homework question here. That's 1.3. All right, so if you need more examples, I can. But so they ask you to use Modus Ponens or Modus Tollens. Fill in the blanks in the arguments so as to produce valid inferences. So they give you the first statement, and they also give you a conclusion. And you need to fill in the second statement, the premise. Maybe I can give you an example for that, because we didn't do that one. The one we did is like number 3. If logic is easy, then I am a monkey's uncle. I'm not a monkey's uncle, therefore, you get it right on the conclusion. Okay, so that's the third one. We did do something like that, but the second one, instead of giving you both premises, they give you the conclusion, and they want you to fill in the blank for the other premise. So we can do example. Exercise number 5 in the book says, if they were, did I switch it? If they were unsure of the address, then they would have telephoned. That's the first premise. And the second one is missing. You have to figure out based on the conclusion they draw. So they were sure of the address. That's right. Okay. So I think we make this kind of, they did not telephone all the time. So if someone did not, you have a party and you give everybody the address, and if somebody is not there yet, and you're wondering whether they are sure of the address, and so your argument, you will be like, oh, maybe they don't know the address, but maybe you say, okay, the argument is, well, if they don't know the address, they would have called, and because they did not call, that tells me the conclusion you can draw is they know the address, right? So that's the kind of logic argument we do all the time in real life. But this is called Modus Ponens. You may not realize the name of it. Okay, now, so a lot of them probably argument is just really common sense. The next thing we are going to do the homework question. You should be able to do 2, 3, and the truth table. We did example for that. Whether our argument is valid. The first 2 examples we do. And also, this one, number 22, is kind of similar to the question James asked at the beginning, the homework number 16. So the first thing, they did not give you any symbols, P, Q, R. You have to pick a letter to represent each statement, whatever letter you want to pick. The same thing here, number 22. It says, if Tom is not on team A, then Guai is on team B. If Guai is not on team B, then Tom is on team A. Therefore, Tom is not on team A, or Guai is not on team B. Is on team B. So you're gonna have to use symbols to write the logic form. So you can make this your P. It's up to you. You can call this P. Tom is not on team A, and Guai is on team B as Q. But if you want, you can make this the negation of this as P. Say Tom is on team A as P, and this will be negation of P. So whatever you like to do is fine. Okay, and then you're gonna change the rest of them to symbols. And after that, you make a truth table to test whether this argument is valid. When you just read it, it's just like very complicated and not on, and you may get lost. Whether this is true or not, this conclusion is true or not. You might have to think hard, not as easy as the simple examples I gave you before. But if you draw the truth table, you can always tell whether this argument is valid or not. Okay, and so next we're going to look at the other type of question. So number 22 or number 6, you have to make a truth table to tell whether this argument is valid. Some of the easy ones, you don't have to make a table. You can tell immediately it's invalid or it's valid. For example, these 2 arguments, whenever you see them, they are going to be valid. You don't have to make a table. You can make a table, P implies Q, P, Q, and you're going to see these are both valid. You can do that after class if you want. It's very easy, much easier than the first 2 examples we did. So whenever you see these, you don't have to make a truth table. You immediately know, okay, that's true. That's a true valid argument. That's a valid argument. Okay, but there are some others that are invalid arguments. You will be able to see without making a truth table. So let's look at those 2 cases. One is called converse error. So I guess we can call this special cases of invalid arguments. Special cases of invalid arguments. The first one is called converse error. The second is called inverse error. I can also put them side by side to compare. A converse error is the one we let's say if it snows, the class will be canceled. If the class is canceled, can you conclude it snowed? Yes. So that you cannot conclude that because there could be other reasons for the class to be canceled. So that if you make that assumption, that would be called a converse error. I can write it down here. What's a converse error? So if P, then Q, that's the same as before. Suppose you say Q, therefore P, that is called a converse error. And as you can see, why we call this converse error? Because you're like saying if Q, then P. We know we call that converse. And we know converse may not be true. Another very easy example is if I live in Columbus, then I live in Ohio. Because I live in Ohio, therefore, I live in Columbus. Is that true? Not necessary, okay? You live in Ohio does not guarantee you live in Columbus. If you live in Columbus, yes, that guarantees you live in Ohio, but not vice versa. So the converse will be true, will be false. But converse sometimes could be true. Say if I there are different cases. So just like the example we had before, if a number is divisible by 3, then the sum of all the digits should be divisible by 3. If the sum of all the digits is divisible by 3, then that number is divisible by 3. So that is true, but not always. So that's whenever you see this kind of argument, you will have to say it's invalid. Why is it? What error is it? It has a converse error in there. Okay. I'm going to give you an example. Let me give you the definition, the format of inverse error. So if P then Q and negation of P, therefore negation of Q. That's a common error we make all the time. The example we gave you last time. If you show up for work Monday morning, then you will get a job. We all automatically assume if you don't show up for work Monday morning, you will not get a job, right? We say in real life sometimes they mean both ways. That's why that is true, but it's not really true. Precisely, you will have to say clearly. If you don't show up for work, you've got to say both sentences. If you show up for work, then you get a job. If you don't show up, you won't get a job. You have to say both. They're not the same thing. Okay, again, the example. So if you say that, if you don't show up, then you don't get a job. That's not necessarily true. If you don't show up, you may still get a job. Okay? Don't make that assumption. And again, if I live in Columbus, then I live in Ohio. If I don't live in Columbus, then I don't live in Ohio. Not necessarily true, right? Okay, as you can see, there are lots of examples to show these two forms of arguments are invalid. Okay, so these both are invalid. The example, I got 2 minutes, so I probably don't have time to finish that. You can use the example that I gave you. Maybe I can do one example, and if I'm cut off, then I'm cut off. So if Zach is a cheater, then Zach sits in the back row. The back row. Zach sits in the back row. Therefore, he's a cheater. Zach is a cheater. Is this a valid argument? Can you tell by looking at them? The first statement says if Zach is a cheater, then he must sit in the back row. The second one, we saw Zach sitting in the back row. We make a conclusion. Therefore, he's a cheater. Is that right? Is this a valid argument?
No.
No, why not? What error is this? Converse error, right? Okay. So when you reverse it may not be true. So this is invalid. It has a you mark converse error. Converse error.
Your meeting has ended.